I want to look at how it works, what the mechanics are behind it, and how we actually set it up to do useful things like pull and lift and tug. So that's what we're going to do. The first thing we're going to do is look at a diagram. This will just give us a chance to understand exactly how the mechanics work inside a Z-drag. So let's have a look at that.
So this is a diagram of the 3-to-1 pulley system, which is the basis of how the Z-drag operates. And it's quite simple. You have a load, which is the thing you're trying to lift or pull or tighten, and your main rope is tied directly to the load. And that rope goes back up to a nice solid anchor point, and it goes through a fixed pulley. From there, it goes back down to the load, where there's a traveling pulley, and out to where you pull on it. Now, if you want to raise that load by 1 meter, you have to pull in this meter of rope, this meter of rope, and this meter of rope. Which means to raise the load 1 meter, you have to pull in 3 meters of rope. So that's what makes this a 3-to-1 mechanical advantage. It's a very strong, simple pulling system. Now, if you want to know more about pulley systems and mechanical advantage and how all that works, you can have a look at my previous video called Pulleys and Mechanical Advantage. But what we're dealing with here is the mechanical system that actually runs the Z-drag.
So this is exactly the same 3-to-1 system that was in the diagram. Rope is tied directly to the load. It runs up to a static pulley, down to a traveling pulley, and that means when you pull on this, you get a 3-to-1 mechanical advantage at the load. So this is a very powerful lifting system, but it's also very simple. Now, if we look at the simplest form of 3-to-1 pulley, or Z-drag, it's called a trucker's hitch. And the reason it's simple is because it only takes a piece of rope to tie it. You don't need any pulleys or anything like that. And the trucker's hitch is very handy for tightening ropes, for tying things onto cars, all sorts of stuff like that. It's a very simple system. So let's take a look at the diagram just to see how it's tied, and then we'll come back and tie one up for real. So let's have a look at that.
So this is how we set up and tie a trucker's hitch. So what you're pulling on is at the top of the picture where it says load there. You make a simple twist in the rope, you feed a little bit of a loop through, you tighten it up, and you've got a slip knot. Your rope then goes down, around whatever you're tying it to at the bottom, tent peg, boat rack, canoe rack, whatever, and up through the loop. And this works just like a 3-to-1 pulley. The slip knot works as the traveling pulley. The bar at the bottom works as the fixed pulley. When you pull on the rope, it's exactly the same as our 3-to-1 pulley system. So let's see how we tie that.
Alright, so just like in the diagram, we've got our rope anchored up on whatever it is we want to pull or tighten. So we'll hook up that up there. That's what we want to pull on. So the first thing we need, just like in the picture, is that little slip knot. So we give the rope a twist, and we just pull a loop through. And we have that little slip knot. So then we take the other end of our rope, it's a long rope, and we put it around whatever it is we're tying to. Whether this is a tent peg to tighten the guide rope, a tree to tighten the ridgeline rope, a roof rack to tie your canoe on the car. Whatever it is, the rope goes around it, and then your end goes through the slip knot. That's all there is to it. When I pull on this, this rod is acting as the fixed pulley. This loop is acting as the traveling pulley, and it's pulling right here to put my 3-to-1 pull on this rope. So I pull down here, and I'm putting a 3-to-1 pull on my load up here. That's all there is to a trucker's hitch. It's exactly the same as a Z-drag, exactly the same as a 3-to-1 pulley. It only needs a single piece of rope. So let's just look at the picture and see how closely it resembles the actual 3-to-1 pulley.
And that's what it looks like. The 3-to-1 mechanical system on the left, the trucker's hitch made out of a single piece of rope on the right. Easiest thing you can do. All right, let's move on.
So that's the trucker's hitch, the simplest form of Z-drag, the simplest form of 3-to-1 pulley, tied up with just a single piece of rope. Now we're going to go on to the Z-drag, and this is the main pulling system that we use to do all the lifting and pulling and tightening and things like that. Uses a little more equipment, but allows you to do a whole bunch of things. So the first thing we're going to do is we're going to look at a picture that will show us what's exactly different between the way the Z-drag functions and how that normal 3-to-1 pulley functions. And then we'll look at how we actually set up the Z-drag and make it work for us. Let's go.
So here's the Z-drag. Simple setup, exactly how you would normally do it. On the left would be the load, on the right is your anchor point, the lower rope is what you pull on. So let's connect that up with the 3-to-1 system we've been looking at and see what the differences are. So the Z-drag is on the top, the main pulley system is on the bottom, and as you can see, they're exactly the same mechanically speaking. The difference is on the Z-drag at the top, you have two little white prusik loops that are used to control where the traveling pulley is on the main rope in relation to the load. And these prusik loops are very important. That's what makes a Z-drag applicable in so many different situations. So let's look at that prusik loop and see what it actually is. So this is a prusik knot, around here known as an alpine prusik knot. It's simply a small loop of rope that's tied around a larger piece of rope. It's a friction hitch that'll move along the rope. And it's very simple to tie. All you do is put the loop around the rope through itself, around the rope through itself again, and you tighten up all the bits. The only thing to remember about a prusik knot is that the loop itself, the diameter of the actual rope, is recommended to be no more than 60 to 80% the diameter of the rope it's being tied around. If the diameter of the prusik loop rope is more than that, or it's approaching the diameter of the rope it's tied around, the loop may not lock securely and might slide when it's under load. So that's something to keep in mind.
So this is the prusik knot, just like in the picture. And what it is a friction hitch that will lock onto the rope. Now, if you grab the knot itself, it slides up and it slides down. It slides up, but if you pull on the loop, it locks and it won't slide along the rope. If you slide the knot down and you pull up, it locks again and won't slide on the rope. So what you have is a way to put an anchor point on a length of rope and then move that anchor point to wherever you might want it to be. So this is very, very handy. If I want to pull from up here, I just put my prusik knot up there and I can pull from up there. If I want to pull from down here, I move my prusik knot down and I can pull from down here. So this is a very, very handy thing to be able to use. And it makes managing our Z pulley very simple. So let's have a look at that.
So here's a Z pulley all set up and ready to go. The load is at the top, that's what I'm trying to pull. The rope comes from the load up to the fixed pulley at the bottom and down to a traveling pulley. Now you can see here that the traveling pulley is anchored onto the main rope with a prusik loop. There's also a prusik loop at the top that anchors the main rope between the traveling pulley and the fixed pulley. And those two things allow you to manage the traveling pulley. The way this works is very simple. As I pull on the rope, the weight from the load is transferred to the prusik loop on the traveling pulley. And the traveling pulley comes towards me, moving the load. I pull it until the traveling pulley can travel no further, then I release the tension and the weight of the load is transferred to the prusik that's on the fixed pulley. And that's how the system functions. Now, one of the trickiest parts of this operation is managing the Prusik loop at the fixed pulley. It can cause a few problems. So let's see what we can do to fix this. So I've set up this pulley here just to show what can happen when you're doing your Z drag. So this pulley is the fixed pulley at the top of the system. So this is the rope that goes out to the load. This is the rope that goes down to the traveling pulley. So we're pulling this way. Now if everything's working perfectly and your Prusik's exactly the right size, your rope's exactly the right size, you've got exactly the right sized pulley, then it works just fine, and as you pull, the rope slides perfectly through the Prusik loop and you're drawing up your traveling pulley. Then, when you release the tension on the traveling pulley, the rope locks tight. And that's how it's supposed to work. However, in real life, what very often happens is that this Prusik here will come up and it will jam in your pulley. And now your whole system is failing. Now, in real life, what we tend to do, because this is quite a common issue, is that we have someone managing this Prusik. So he just hangs onto the Prusik, and you can just pull your rope smoothly and easily through the system. Nothing ever binds up. But if you don't have that second person, or if he isn't paying attention when you give a good pull, your Prusik can get up, still jam in the system, and now your whole system is locked up. There's nothing you can do. If you're by yourself, and what I've done in this demonstration that we're going to see, is I've just put a little piece of plastic pipe in here that prevents the Prusik from jamming into the pulley. So let's see how that works. So I just cut a little piece of PVC pipe about 1.5 centimeters long, and this just sits loosely on the rope between the Prusik knot and the fixed pulley. And it will help prevent the rope from jamming in the pulley. So let's see how this works. So with this little piece of plastic in place, this Prusik will never get caught in the pulley. It's still fine when you let go, the Prusik takes the load, and the rope locks. And this little piece of plastic just sits here until you're ready to pull again. Okay? So just a little piece of plastic like this, kept in your kit, can go a long way to reducing the number of headaches when you're setting up your pulling system. So here we go. I pull on the rope. The Prusik on the traveling pulley takes the load, and the traveling pulley travels towards me. Gets as far as it can. I release the tension, and the Prusik on the fixed pulley takes the weight. Now I can loosen the Prusik on the traveling pulley and move it way back down the rope again, and I'm ready to pull. Now when I pull, the traveling pulley takes the weight again, the Prusik at the fixed pulley slides, and the traveling pulley pulls towards me once more. And this is the system. Release the pressure, fixed pulley Prusik takes the weight, and you move your traveling pulley back down the rope. And you do that until you've moved the load as far as you want. The goal, of course, is to have as much travel room as possible when you start to pull, and have your traveling pulley as far down the rope as you possibly can, in a perfect world, right at the load, so you can minimize the number of times you have to move your traveling pulley before your task is complete. So when you're setting up your Z-drag, you want that traveling pulley as far down the rope as you can before you start pulling. And if you do that, you may be able to finish your pull without having to reset that traveling pulley even once. However, you may often find that you have a very short pulling distance, and you may have to reset that traveling pulley any number of times before your task is complete. So that's the basic Z-drag system. But there is one more thing we can do that can make your system pull easier in a lot of tricky situations. So let's have a look at that. So here's the 3-to-1 pulley system. The same thing that forms the Z-drag. Now, there's times when you won't be able to pull too far in this direction. Perhaps your anchor's
right up against a cliff, or the ground's really rough, or you don't want to pull in that direction. So you need a way to change the direction of pull. And to do that, all we do is put in another static or fixed pulley, just like this. So what I've done here is I've added a second static or fixed pulley to the system. Remember, these pulleys don't have anything to do with the mechanical advantage. They just change the direction of the pull. So now, instead of having to pull straight up in this direction, I can pull down in this direction and get exactly the same 3-to-1 mechanical advantage in my pulley system, or my Z-drag system. It means that if there's a cliff here, and there's the edge of the river here, I can pull sideways and still get my 3-to-1 mechanical advantage in my Z-drag system. So, this happens more times than you might want to think. We'll look at a picture here of a place that I had to use a second fixed pulley to let my direction of pull change dramatically. So here's what that looked like.
So in this situation, I had my 3-to-1 Z-drag hooked up to the end of the canoe and up to my makeshift lifting tower. But there was no way I could pull in the direction parallel to the rope. But the addition of a single fixed pulley at the top allowed me to pull from the side, and it worked absolutely perfectly. So that's the way a directional pulley helps when you're trying to set up your Z-drag.
So that's it. Everything you needed to know about 3-to-1 pulley systems and how to set up your Z-drag. If you liked that video, and if it did the job helping you understand how a Z-drag works, press the little subscribe button down there, and that'll help me out. If there were things that didn't come across clearly, or things I forgot to mention, send me a little comment, and then I can work it out or answer any questions that anybody might have. All right, thanks for watching.